Assalamualaikum and good day. Today we are going to discuss about our project for the BMCG 3613 Fluid Mechanics assignment, which is the drag and lift computational fluid dynamics. So our team consists of our leader Vimalan, Said Muhammad Ashraf, one Muhammad Hafizi, and one Azlizam. So for this project, we will be using ANSYS software as our computational fluid dynamics mode, and we will use its numerical analysis and data structures to analyze and solve the problems that will be involved. So the problems will be involved include the fluid flows and the drag and lift calculations. So the methods involved are dimension definition, meshing and elements, boundary definition, and resultant detailed view.
Hi, my name is Vimalan. Today we would like to use Fluent to analyze flow stimulation. Okay, first of all we have to click the Fluent. Then next geometry will pop up. Click the geometry and you click design modeler. Once the design modeler pop up, click make sure the dimensions are in the meters and click Z axis. Then click XY plane, create a new sketch in the XY plane. Once you create a new sketch in the XY plane, click rectangle, then click the X and Y origin, create a rectangle there. Next click dimension, then define dimension as H1 is 2.5 and V2 is 0.45 meter. Once you define the dimension, next click fillet, sketch a fillet. The radius should be 0.2. Next click modeling, then click the sketch that you have been created recently, then click extrude of 0.16 meter. Next click direction, choose the option of both symmetry, then generate, click generate. Once you generated, you can see the design that have been created. Next click tools, select enclosure. Now we have to define the dimension of the enclosure. For FD1, put the dimension 8 meter for X axis positive, FD2 Y axis positive 1.1 meter, FD3 Z axis positive 1.5 meter, FD4 negative X value would be 8 meter, FD5 negative Y value would be 1.1 meter, FD6 negative Z value should be 1.5 meter. Once you done define the dimension, click generate. Once you generated, you can see the enclosure design. Next, go to create, choose the option of boolean. Once you choose the option of boolean, click apply. Once you already apply for both target body and tool body, click generate. After generate, you can see there is only one part and one body together. That's it from my side. Thank you.
For this part of the section, we will be looking at the mesh. So first off, we select the mesh, and we will be doing the inflation for the mesh. So insert and press inflation, and we select all the geometries to one body and select all the boundaries. We deselect them so that we will only select the innermost part, which is the truck. We change the maximum layers to 10, and the sizing, we will be changing the max size to 0.5 and the element size to 0.2, and we will generate the mesh. As you can see, this is the mesh. We can do a section plane where we can see the innermost parts, so we can see the cross section of the hollow generated mesh. Now we uncheck the section plane, and we will be able to see the qualities. So the mesh matrix to skewness, and the skewness is very low. There are a bit of errors. And we can check the element quality, in which it is high quality, since blue represents a maximum quality while red is minimum, and we have seen none of the red. And now we shall go to this naming part, and we will name this the inlet, and we'll name the other the outlet of the stream. We shall name the sides as the walls of the system. And we shall select all except we deselect the outside. As you can see, it's all just the inside, and we'll name it as the truck, and we update the mesh, and that is all for the meshing.